Have you ever just looked up at a giant tree? I mean, a really giant one, like a redwood, and thought, how on earth does it get a drink? It sounds so simple, right? But it's actually one of the biggest physics puzzles in all of biology. So how do they pull it off?
Okay, so to put this in perspective, think about a skyscraper. To get water all the way up to the top floors, engineers have to use these massive, powerful pumps that just chew through electricity. It's a huge engineering challenge.
And yet, a tree that's over 100 meters tall, that's more than 30 stories, it does the exact same thing. And it does it silently. With no moving parts, no power cord, it's constantly battling gravity and the friction inside its own pipes, every single second. So, what's the secret?
Well, for more than 100 years, scientists have had what seemed like a perfect, really elegant answer. It's a theory that's basically been the foundation of plant biology for ages.
It's called the Cohesion-Tension theory. And the idea is pretty simple, really. The tree acts like a giant straw. The sun beats down on the leaves. Water evaporates. That process is called transpiration. And this evaporation creates an incredibly powerful suction force. So here's the breakdown. As one water molecule evaporates from a leaf, it literally pulls on the molecule right behind it. See, water is super sticky. That property is called cohesion, so it's like they're all holding hands. The whole column of water gets yanked upwards, all the way from the roots, like a tiny, invisible chain reaction happening inside these little pipes in the trunk called the xylem. Okay, and this is where things get really wild. Those little bonds holding water molecules together, they give water a tensile strength that can hit 45 megapascals. Now, what does that even mean? Well, that's like 450 times the pressure in your car's tires. We're talking about water that is molecule for molecule as strong as a steel wire. It's insane. And that's what makes this whole giant straw idea even possible. So you might be thinking, if this system works so well, why aren't there trees that are, a mile high? Why do they stop growing? Well, it turns out this super elegant theory starts to show some cracks. It all comes down to something called the hydraulic limitation hypothesis. Basically, the taller a tree gets, the harder and riskier that journey is for water. So the tree is forced to make this really tough choice. Do I move water fast, or do I play it safe? And you can see that trade-off right here in the data. In shorter trees, those little connectors between the water pipes are nice and wide. Water flows super easily. But in the really tall trees, those connectors have to shrink down. Why? To stop deadly air bubbles from forming when the tension gets too high. It's a safety measure, for sure, but it also starts to choke off the water supply. And the effects are really obvious if you just look at the leaves. Way up at the top of a giant redwood, the leaves are constantly thirsty. They're basically in a permanent state of water stress. They actually become small, kind of scale-like, just to hang on. Their internal water pressure, that's called turgor pressure, is super low, so they're not as good at photosynthesis compared to the big, happy leaves down below. So all of this leads to a hard physical limit, a ceiling. For coast redwoods, the tallest living things on the planet, scientists have calculated that somewhere between 122 and 130 meters, the whole system just grinds to a halt. The water flow would pretty much hit zero. That's the end of the line for growth. And for decades, that was the story. A brilliant system, yeah, but one with a clear limit. But what if there was more to it? Because a discovery just this year, in 2024, dropped a massive plot twist into the century-old story. You see, there's always been this little mystery nagging at scientists. Whenever they actually managed to measure the pressure inside those xylem pipes, it was way lower than the classic theories that it should be. Something didn't add up. And that led to a huge question. What if the pipes aren't just pipes? And the answer to that question is a total game changer. It's a complete paradigm shift. We went from thinking of the xylem as just plumbing to realizing it's an active engine, a pump with no moving parts built right into the walls of the pipes themselves. So using some super advanced imaging, think of it like a souped-up MRI for trees, researchers found something unbelievable. These things called hierarchically helical molecular pumps. It's a mouthful, I know. But what it means is that the walls of the xylem are lined with these tiny, spiraling fibers that are actively helping to pump water up the tree. And they're doing it with almost zero friction. And this little nano engine, it's a work of art. You've got these spiral fibers that guide the water's path. Then the spirals get narrower in spots, which creates this thing called the Venturi effect. It's basically localized suction that keeps pulling the water forward. Then there's this weird single layer of water that's almost like ice, acting as a perfectly frictionless lubricant.
And get this, there are even these little horizontal gaps that act like rungs on a ladder, creating new ground floors for the water as it climbs. Now, let's be super clear. This doesn't mean the old cohesion-tension theory was wrong. It's just incomplete. That suction from the leaves is still the main driver, the big picture engine. But these new molecular pumps, they're the secret weapon, the nano engine inside the trunk doing all the really hard work, making the whole thing way more efficient than we ever dreamed. Okay, so why does any of this matter? This is way more than just a cool biology fact. Figuring this out has huge implications for, well, for everything, from the health of our planet to the kind of tech we'll be using in the future. So, for starters, the bad news. This tells us that our oldest, tallest trees are really living on the edge. As the climate gets hotter and drier, these giants are at huge risk. But there's an amazing flip side. This incredible natural pump is inspiring a whole new wave of technology for everything from cleaning water to moving fluids around more efficiently. And I mean, get this, scientists have already built artificial pumps based on this tree design. And they don't just move water. They've shown that they can actually generate electricity while they're doing it. How incredible is that? So that leaves us with this one kind of mind-blowing thought. For over 100 years, we thought we had this figured out. And all that time, there was this hidden molecular engine working right under our noses. It really makes you wonder, right? If trees can hide something this complex, what other incredible secrets is the natural world just waiting for us to find?